Okay, so I'm going to go ahead and add another video to my library, and it's about using task parallel library in .NET. So it's basically dealing with asynchronous programming in .NET. So mostly in past I've been working with just using async and await without really knowing too much about different ways that you can do the multitasking and .NET, and one of the ways is by using this task parallel library. So this is the example by Philip Ekberg from Pluralsight, and basically he created an application like this. It's a Windows program, and as of this moment the program runs synchronously. So if I click search here, it opens up the large file, processes the file, loads it into the list of objects, and then ties it to this grid view here in this Windows form. So what I really want to do is introduce this parallel library in code, and here's the code. So basically, as you can see here, it loads CSV file into string of arrays called lines, and then it just loops through each one of these lines, and then using this little thing right here, for loop, it puts it into the stock price object. A perfect example here is that we can use Task.Run, and the task parallel library basically is based on that concept of task, and task represents asynchronous operation. Using task, we can schedule work to be executed somewhere else on a different thread. Task.Run queues the work passed as the action to run on a different thread by using the thread pool. So let's go ahead and see how we can use this task in code to basically put this on a different thread. So before I continue with introducing the task, I just want to show that if we use a different library, the one that has asynchronous way of retrieving the data, we can just simply use that and then just use async and async and await, and we can have this process run asynchronously with async and await. But if we don't have a way of finding a library, for example, that has this await option to read the data, then we definitely need a task. Okay, so what we need to do, we want to go ahead and introduce Task.Run. So here's our Task.Run, and what we want to do is we want to go ahead and put the code that we want to execute somewhere else inside of this Task.Run. And I just copied and pasted all of the code, including the part when we need the data to be displayed back in the UI, and that's actually going to be a problem. So when I try to run, now I'm not getting any data. It says it loaded everything 0 milliseconds, but nothing is there. That's because all this now is running on a different thread. When we are trying to put this data back, it's just some different thread. We can't put it back on a UI thread. It doesn't know where it is. So in Xamarin, we can use this dispatcher.invoke to get the things back onto our UI thread. Okay, so the only problem here is that this will be queued instantly, will be put on a different thread to run instantly, but the code will continue to run, and then we will continue to run here, this area of the code. So if we run this code, basically it's not going to be correct, because we'll see that it shows us that it was executed in a very short amount of time, in like a 1 millisecond. So in order to do this, we can introduce this back to the async and await, and we say this is async, and then we just await this task. So what this will do is it will actually rewrite this whole method, but I don't want to go too deep into that right now. So what it will do is it will actually create a continuation as it's supposed to be. So it will queue this, it will execute it, but the code will continue to run in a sequence. In other words, this will be a continuation of this. So if I do this, Control F5, MSFT, and now the code actually ran correctly. It didn't lock our UI thread, and it showed the load bar, and then it loaded our data.